This lesson is on Chapter 7, Section 9, titled Similar Solids. We've done a lesson like this a little bit in previous chapters, but we're just comparing similar solids in this example. So similar solids have the same shape, their corresponding linear measures are proportional, and their corresponding faces are similar polygons. So if you can look at this, this shape is similar to this shape. They have similar shape, their measures are proportional, and their faces, these are their faces, are similar polygons. So let's jump right into an example here. It says the cones at the left are similar. So you can see that both of those cones look the same. One's a little bit smaller than the other, but they're similar. So now I want you to Okay, so we're going to find the height of cone A. So what we're going to do is we're going to set up a ratio. We're going to go from the big cone to the small cone to figure out that missing height. So I'm going to first compare the heights. I'm going to say 8 is compared to that unknown value of x. So 8 is compared to x. Again, I'm just going to title that x. That's our unknown. That's what we're trying to solve. And I'm going to set that equal to 4, our radius 4 in this triangle is compared to 3. I'm sorry, not a triangle. I always say triangle because it's similar to a triangle, but it's a cone. I'm going to compare the radius 4 to the radius 3. So I'm going to write the ratio 4 to 3. So now this looks very similar to what we're used to solving. I'm going to kind of compare these fractions. Again, these are equivalent fractions. So I know to go from 8 to 4, I have to divide by 2. So I'm going to think of what number divided by 2 is going to equal 3. Or think of 3 times 2 has to equal 6. So I can compare the ratios. Well, 8, 6 has to equal 4/3. So I have to say the height of this smaller cone is going to be 6 inches. Again, in order to find the height or a missing measure of a similar cone, all you have to do is set up two ratios and set them equal to each other and solve. My last example, it's a little bit trickier, but as long as you know this formula, you'll be all set. It says the pyramids at the left are similar. Find the total surface area of the pyramid B. Okay, so we're looking for this surface area. And we know that the surface area of A is 180 units squared. So I'm going to look at this formula here. I'm going to take the surface area of A divided by the surface area of B. Again, I'm setting up ratios. It's going to be this equal to A over B squared. And again, it's squared because we're solving for area. So let's kind of break this down. So I know the surface area of pyramid A. Okay, so I know it's 180. Okay, I do not know the surface area of pyramid B, so I'm just going to put B in for that. Okay, I'm going to set that equal to A. So now I can pick any side I want. I'm going to kind of stick with the heights. I'm going to stick with these two when I'm comparing the ratios. So I'm going to compare, so A, again, make sure that you know what the difference of A and B. So A, I'm going to plug in 12 for A, and then I'm going to plug in 3 for B. If you wanted to, you can always plug in 6 and 1.5 because those correspond together. You can pick whatever you want. I'm just going to pick 12 and 3 just because I don't have to deal with the decimal. Okay, and then again, I have to know that this has to be to the second power. So now again, it's just orders of operations. So I'm going to just rewrite down what I know. 12 to the second power is 144, and 3 to the second power is 9. Now we're just going to, solve simple ratios here. It's kind of hard to find a pattern between 180 or a relationship between 180 and 144. So again, I can just kind of use that fish method and take 180 times 9 divided by 144 is going to be equal to B. So again, 180 times 9 divided by 144, that's going to equal to B. And again, hopefully we've done this, you guys remember this from the other chapters, but after you solve for that, so we would take 180 times 9, we're going to get 1,620, we're going to divide that by 144, and when we do that, we're going to get 11 and 25 hundredths. And again, because we're solving for surface area, and we don't really know what's, we know the units is just units, kind of an unknown. That's why we put units there. And then it's the second power. So to kind of recap here, this is that formula you kind of have to understand here. Kind of one that I would just kind of memorize. So, and again, because we're comparing surface areas, we're just going to take the surface area that we know, divided by the surface area of the unknown, and then we're just going to pick any two sides that correspond together, and we're going to put it to the second power, and then solve from there. So hopefully it's not too difficult, and that brings me to the end of this video. Thanks for watching.